All right, wavelength and frequency. We talked about that yesterday. We're going to do some calculations today, and that's where I'm talking about you got to have your calculator to make this work. Okay, guys? So we've talked before about our calculators and how to get to that 10 to the x, which on most of yours is an EE key. For some of you, it's this. And for some of you, it's a key that says EXP. So these will all work and function in the same way. When you press these, they will give you, they expect you to enter another number in. So for example, if we had 6.02 times 10 to the 23rd, we wanted to do that. I would go 6.02. I'm not going to put in times 10 to the. This key, whichever key you have on your particular calculator, replaces these keystrokes. So then it will sometimes, when you activate the EE key by pressing either the key or you have to hit second, and then this is above the key. Okay, and a lot of your calculators have a comma here, and then the E is right above that, and then the number 7 is here. So that's kind of the way that works. When you activate that, then it'll read on your screen E, and then you're going to type in 23. This EE or these things take the place of this. Do not press the times key in this string. If you do, you will get the wrong answer, usually by a factor of 10. Okay, just kind of a review on that. All right, properties of waves. Some things that you need to know to be successful here. This is one of our equations. The equation is speed of light equals wavelength times frequency. Your speed of light is 3 times 10 to the 8th meters per second. So you can think of that as 3.00 times 10 to the 8th meters per second. So this seconds is on the bottom line. Okay. Wavelength has to be in meters. So if you are given kilometers, remember that 1 kilometer equals 1,000 meters. Sometimes you are given nanometers. Okay. There are 1 times 10 to the 9th nanometers in every 1 meter. So this is a very tiny thing that you can't even see with your eye. So this is a common conversion factor that you are going to need throughout this unit. Okay. If you want to get a perspective of this, there is 1 times 10 to the 3 millimeters in 1 meter. There is 1 times 10 to the 6th micrometers in 1 meter. And then there's 1 times 10 to the 9th nanometers. You guys can visualize what a millimeter looks like, right? This is 1,000th of a millimeter is a micrometer. And 1,000th of that is a nanometer. So that is so tiny that you wouldn't be able to see it with a naked eye. Okay. The other thing that you have to do is have your frequency in hertz. Remember, hertz is 1/seconds. It is also, if you're familiar with inverse, it could also be thought of as seconds to the -1, if you're familiar with inverses. Everybody in here is at different levels of math, so I don't know if you understand inverses yet or not. Hertz, then, sometimes you're given megahertz. Okay, in 1 megahertz, you have 1 times 10 to the 6th hertz. And sometimes you're given in kilohertz. There's 1 times 10 to the 3 hertz in that, or 1,000, however you want to think about it. Okay, so these again are conversion factors that you want to be familiar with because you're going to need to use these throughout this unit. Questions on those? All right, let's go do some math. I think I gave you, why did that go there? Sorry. I think, is this on your note sheet?
Yes.
Okay. All right. So this is what I was talking about. I gave these in your note sheet. One of the other things that you're going to need to know about is moles. Okay. We have a counting unit called a mole. And a mole is 6.02 times 10 to the 23rd of anything. It's just like a dozen, but a dozen is 12. This is 6.02 times 10 to the 23rd. So for example, on the periodic table with your masses that are up there, if carbon's mass on there is 12.0, if I have 12.0 grams of carbon, that means that I've got 6.02 times 10 to the 23rd atoms of carbon. Okay, so the mole is our conversion unit in chemistry. We use it to convert between a lot of different things, and you're going to start hearing about it from here pretty much on out. Okay. So questions on any of that? Yes, ma'am.
Wait, is the H equal to 6.26 times 10 to the negative 34 power or 20?
This is 34th. I don't know what happened to that. That should be, that the meters per second should be up here. Is that better? Mm-hmm. So this, the H, remember we talked about that yesterday. That's Planck's constant. And it's 6.626 times 10 to the negative 34 joules seconds. So these are on the same line. All right. So now that you are armed with all that goodness, we are going to move on and do some problems. Okay. So here we are solving for frequency in our problem. And when we're solving for frequency, we have two equations that we can use. We have this guy and we have this guy. Okay. The one that you use is whatever you're given. So you're given wavelength here. So which one of these, our first equation or our second one, which one of these has wavelength in it? Yep, the first one. Okay, so this first one, this is speed of light. This, remember, is wavelength, and this is frequency. So we are solving for this. How do we get this by itself? What do we do to this equation to get this guy by itself? Right. So if we want frequency, that's going to equal C over wavelength. Or I'm sorry, if we want frequency, we want speed over wavelength. Good? All right. So I'm going to go to my sheet here, and I'm going to find the speed of light. That is listed right here. Okay. I'm going to write that in. So that's 3.00 times 10 to the 8th. That's going to be meters per second. Then I'm going to put my wavelength in. But there is a problem here. This is in nanometers. I can't use this in nanometers. I have to have it in meters. I need to have it in meters. Otherwise, this meters is not going to cancel out. So we're going to go back to our little friend, dimensional analysis. Remember him? Dust off some cobwebs there. I want to get rid of nanometers, and I want to go into meters. Where am I going to get my conversion factors for this? Yep, in your notes right there. Do you see one that you can use for this? Which one are you going to use? What am I going to put down on the bottom here? Right? I'm going to use this guy right here. Okay? So I find the numbers that are associated with nanometers. So 1 times 10 to the 9 is going to go down here. I'm going to find my, there we go. 1 times 10 to the 9, and that's 1. So I'm going to multiply across the bottom, and then I'm going to divide those values. So 633 divided by 1 times 10 to the 9, I get 6.33 times 10 to the negative 7th, and that's going to be meters. All right, what happens to my meters? Anything divided by itself is? No, not 0. 1. So this guy and this guy will divide out. Those are going to divide out. Does that make sense? You guys have learned that in math, I hope. Where these divide out. Then I'm going to calculate this. I'm going to put this in my calculator. So 3/8 divided by 6.33 7 equals. All right, how many sig figs should I have in my answer? 3. This is the measured amount. I should have 3 in my answer then. So you should get 4.74 times 10 to the 14th. And our units, these seconds are on the bottom. So it's going to be 1 over seconds. Or what is this also equal to? Inverse seconds or hertz. Okay. You need to take your calculator right now and make sure that you can get this answer. If you cannot get that answer, you need to call me over and let me help you with your calculator. That's the EXP. 8. 5. 6.3. Huh? Right. Oh, that's what that line means. And that again. My negative on this calculator is here. And 7.
Yeah.
Who needs the lippy?
We divide my
I don't even charge the thing.
How do you do it?
Then you get this, which is basically
Yep.
answer all
Good.
that.
Where's the next
There's a whole holder for it.
Oh, it's down here.
I was trying to get the batteries, but I fell asleep last night. I passed out. I drooled everywhere. I know. It was trash. I was going down to the I got from doing some stuff and that
You know,
one.
but you gotta put in 10 to the whatever.
Yes, I know.
6.33.
Passed out.
Oh, no, okay.
I was laying down. I was going
Yeah,
to go
we converted it, remember? When we converted it. Now you're gonna hit this.
Man, I told Alexa.
And do your negative 7. No, that's subtract. Negative is not here.
I said it was so scared. It was like, maybe it was like $700.
Okay, so go back, clear it out. So 600 133 divided by 1, and then hit your E. No.
I always wake up like 5 or 6 times before sending on the dot, and then I always have to. So like, you know, the alarm's going off, Alexa, Blair, at like 6 in the morning, because that's when I set the first alarm.
So then you just back up your desk.
It's coming. So it's Blair, and I go, Alexa, shut up, every morning. So she shuts up, and I go, like, I'm still in the days, I don't want to leave my phone. Right, and then I go, Alexa, what time is it? She goes, 6:33.
633 divided
But I
by
know there's another alarm going in 15 minutes, so I gotta go back. Wow. Sticker. No.
Scratch it, scratch it, scratch it. The bubblegum flavor.
Nah, it's all like cinnamon.
That one too.
and then
You ever see in one unrest?
and then type in 8
So the sugar.
there. So you hit divide.
6.33.
6.33.
Like anything.
That is a cool teacher.
Well, apparently
And
you
then hit your
No, my
and
teacher gave me
negative.
in like fourth grade. My
But it
teacher
wasn't
gave
8. It was 7.
I'll teach you.
This
My
was
teacher
another
had to
7.
teach algebra in fifth grade.
Yeah, I was doing all this back in like.
So you must have done something wrong there. That's the answer you should have gotten.
That's when we had that time about it. I was doing.
Everyone's thinking Hayden's doing like.
All right, who needs to eat? That's the units on this. So when you cancel this out, the meters, you had seconds on the bottom. So that's what that is. It equals these things. Just leave that. These confuse you. These things, this equals that. That's the definition of hertz is 1 over second.
Yeah.
Yeah, I'm just trying to show you that sometimes you'll see other units, and that's what those other units mean. All right, anybody else? Yes, ma'am.
Why don't you start taking out to 200? Why you say that for? You think I'm smart enough? She doesn't think I'm smart enough. No. Well, wait, I'm already thinking about stuff. Junior, senior type stuff. So I gotta like put a buffer in there. So
Hey, stop. I told you don't put that times 10 on that. Okay,
I love
it's
it.
second,
Hayden, are
and
you
then the
wrestling?
EE, and now put in your 8. Okay, that is the same as, okay?
That can actually do it. Nah, for right now, as of right now, I'm gonna just try to get a job.
And work out. I don't think I'm gonna.
All right, who else? Anybody? Everybody's able to get that. Make sure you're paying attention and doing this. Don't blow this off. You will regret it. All right, here we go. Everybody was successful on this one. Let's move to the next one. We have a frequency here, and we are solving for wavelength. So this time, we are going to rearrange this equation, since it's the only one with wavelength in it. We're going to rearrange this, so we are solving for wavelength. So what would wavelength look like when it was isolated? I want to get this by itself. How do I do that? Yes, we divide by frequency. So C over frequency is going to equal wavelength. So I'm going to go in and sub in what I know. That is my constant for the speed of light. Remember that hertz is 1 over seconds. We've talked about that. So I'm going to put this guy in for this. So 4.80 times 10 to the 17th. And then the seconds are on the opposite line. So they're going to go up here. These seconds here are these seconds right here. My seconds then are going to cancel. And you're going to throw this in your calculator. And you need to practice this. Do not blow it off. you should end up with a wavelength then of 6.25. And yes, I want 3 sig figs for my answer, times 10 to the negative 10, and my units are going to be meters. So this is what you should end up with for your answer. Make sure you can get that plugged into your calculator properly. I want everybody to try this. You need to know how to use your calculator, or you are going to have a very painful experience with this chapter.
It's been saying that from 113 now.
Because that's
Yeah. I know. I just,
1
when we
over
suffered,
7.
I mean,
That's the units for hertz.
man, I'm sure should be ass wrong.
I wanted to play with these.
I just did so many.
Okay, you see how you're typing in the times here? Don't do that. 3. Oh, I did that for you. Never mind. Okay. So 8. Now with this calculator, because it is nasty, unfortunately, it's frustrating. Okay. I should hit divide on there. Okay, so hit divide. Now, the next key you hit is parentheses. This model.
I don't want to smell that real.
That key again.
Like, I'll be
Exactly.
because then I can smell myself.
I'm gonna close my parentheses and hitting this.
That
That guy is me.
His general.
Sorry. All right, who needs me? Anybody not able to get that? Did you try?
I don't know about that one.
You tried this? You
He
came up
was
with the
trying
right
to get
answer?
me to do some stuff and things. I'll tell you what. He's a bad apple. You know when you like got an apple tree in your backyard, thinking of
Let's look at, I was actually gonna ask
you see the one at the very top, fell to the bottom, a little chunk out of it. That's very
Do
bad apple.
what?
to do some equations.
That's a bad apple. That's a good.
I'll be
For a little bit, but I have a
I like how
kickoff
Paige
meeting
worked
today
her
after school, I think.
Oh my.
Also
Um,
like the weird looking.
But ask questions now.
Not like small apple.
All right, anybody else? Problems with this guy? Okay. All right, here we go. We've got, with this, they've given us a frequency. That frequency is in megahertz. So before we can proceed, we have to change our megahertz into what? Hertz. Okay, so I'm getting rid of megahertz and I'm going into hertz. And I'm going to find a conversion factor that's going to help me with this. Find it. Yes? You get it put in the right spots?
Yes, ma'am.
So you should have ended up with 9.85 times 10 to the okay. Your calculator might have read this. Okay. This is the way my calculator kicked it back. But remember how to do scientific notation. You move your decimal point until your number is between 1 and 9. So my decimal is here. How many spaces did I move that? 7. Okay. So 9.85 times 10 to the 7th. If I move it this direction, this value is positive. Okay. We are solving for wavelength, just like we did in our previous problem. So that is the formula we are going to use. And now I start subbing in my known values. My speed of light is a constant. Oops, wait. Bad lippy. And that's meters per second. Okay, now I am going to put in my frequency. Remember that this hertz is the same as what? One over seconds. Okay, so I'm going to go and put in 9.85 times 10 to the 7th, 1 over seconds. So that means that this seconds is going to go on the opposite line. This seconds came from this number. Once I do that, these seconds end up canceling, and that leaves my answer in meters. Does meters make sense when we are solving for wavelength? Yes. Okay, so let's see if we can get this to come up right in our calculator. I ended up with 3 point, how many sig figs? 305, and that's going to be meters. There is my answer. Okay. Good. Questions? Issues? You need to make sure that you're getting this answer to come up in your calculator. Yay or nay? Did you try it? Did you try it?
I don't know what that.
If I rounded up, if I rounded all the like hexadecimals, it would equal that.
So I
Like a yellow
Chris,
I multiplied that by 1 times 10 to
Well, it's clearly a green
So you can't
the 6.
or whatever the green one.
I would go back to decimal. 1, 2, 3, 4, 5, 6, 7.
Wait, but is Granny Smith green?
All right, what else? Anybody else? Need to help anybody? Talk to me. Let me help you. Did you get this answer? Did you try?
Yeah.
No,
You added them?
I like added them into the equation. I didn't just do these.
yeah, that makes you so mad. I want to pull my nose.
So look, what I did, I took everything from here instead of just like, so these two values, I did like all these elements. Plus, I got this.
Yeah, it's not the same answer.
Sometimes I'll say no.
But you don't have that one. Remember, you have the 15. That's why that one was wrong. This is the right answer.
Is that what it says?
All right, who needs me?
No.
You're good? Everybody's good? Everybody's happy?
See, if I want to say I'd write it. I'd love to.
So like,
Hybrid.
All right. Let me look at your homework real quick.
I literally wore.
why aren't you wearing your phone?
Because I don't want to
Too flash.
I don't want to wear
Too flash.
You know, that's my brand.
You made that?
Okay, so we are at the point now where you are going to practice this for homework. You need to practice it because tomorrow, listen to me, tomorrow we're going to add one more thing in, which is the Planck's constant energy equation. So you need to have this down solid before we add one more thing into it. Okay? So make sure that you're practicing this tonight. I want you practicing it right now. You've got 10 minutes. You're not packing up and quitting on me.